Volumes by solids of revolution. So I'm not going to go through the derivation, but the derivation is in your notes for you if you'd like to go through it. Essentially the same derivation for area under the curve, but when you rotate it, you multiply it by, y squared and pi. So the formulas that you want to know is v equals to pi y squared dx, and that's only if you're rotating around the x-axis. So there's a way I kind of remember it is like, what axes are you rotating around, right? Because you can rotate by both axes. If you're rotating through the x-axis, then you write dx, and your limits are always going to match x1. Your limits are always going to match this, whatever you write here. Then you just write the opposite letter squared, and then you put a pi at the front. That's how I remember it. So you start with what they ask you to rotate by. I think in this example, they're rotating by the x-axis, we say. With this, you can actually derive the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. And you can actually derive it by starting off with a semicircle, because a semicircle rotated will actually make a sphere. So you get a semicircle, you rotate it, and you can actually see you get 4/3 pi r cubed. Rotation about the y-axis, that means you start with writing dy, you get the opposite letter, go x squared, and then the limits here are important. The a and the b is on the y-axis. So just remember with your limits, if you're ever doing anything with volumes or areas, these limits needs to be the dy or the dx values. So if it's dy, they have to be y values. If it's dx, they have to be x values. That's an important concept. Volume by subtraction, pretty straightforward. You just get the higher curve subtracted from the lower curve. So for example here, we have a parabola and we have a line. The parabola is clearly the higher curve. The line is the one that's below in the points of interest. So we just get the parabola minus the line, and we revolve that. So a function just becomes the function divided, here we go, y2 squared minus y1 squared. So don't forget to square it first. You can revolve it both ways. So remember, revolving around the x-axis is dx, and we have 0 to 2. 0 to 2 is x values. See, 0 to 2, x values. The y values is 0 to 4. 0 to 4. If we rotate by the y-axis, then you say dy. Then we want x squared minus x1 squared, and it's 0 to 4. So don't mix those up. There's some volume questions you guys can practice. It's all essentially the same. Here we have some curve. You can see the upper curve there, the one that's at the top. There's the curve that's in the bottom, so you just do the top curve minus the bottom curve again, and you can revolve. Sometimes they ask you to find the points of intersection so that you know what the limits are. Like they won't give you this 0 and 2. So you just have to equate the two equations, and you'll be able to find the points of intersection to use for your limits. Some more. There's a HSC question, revolving volumes. Another one here. You guys can practice this. See, you have to find the point of intersection there. So if you're rotating by the x-axis, you'll use this. If you're rotating by the y-axis, you would use, I don't know if that would be useful, it depends. Because you might have to split this up. You can't go 0 to this value, and you can't go 12 to that value, because you'd only get half of it if you're doing y. So it looks like it's revolving around, it's revolving around the y-axis. So you'd have dy. You find the point of intersection, which is, I think, ends up being plus or minus 2. And they went from 0 to 4. So 0 to 4, I don't know what's going on here. Total volume equals the volume generated by the x squared from 0 to 4 plus the volume generated by x squared equals 6 minus y. So it doesn't look like they did. What they did is it looks like they split it up into two shapes. They split it up into two shapes, and they've added it in. Couldn't do the subtraction. I'm trying to figure out why the subtraction didn't work in this case. Because you should be able to get this and then subtract it with that volume. Find the points in the curves and the volume sort of shape is divided by the axis and switch usually two parts. Yeah, I'm trying to wonder why the subtraction method doesn't work in this case. 12 minus 2x. I'm going to assume it's because of the nature of the... No, they're pretty simple formulas. For the interest of time, I'll come back to this once we've finished the remaining sections. But yes, you can practice more of these rotation volumes by rotation. I'll come back to this question. But